Okay, let me read the question now. By applying the horizontal line test, determine whether each of the following function has an inverse function. So as you can see here, you have graph A, graph B and graph C. So you need to identify whether each of the following function has any inverse function or not by using the horizontal line test. Okay. For the previous example, we used the vertical line test to determine whether each of the following graph is a function or not. Okay, so that is the difference between the vertical line test and the horizontal line test. Okay, so I hope you guys are clear about this. So from here, let us move on to the discussion, for starting with the question part A. But before moving on to the discussion, so you need to know what is the horizontal line test mean. Okay, so this horizontal line test means that, so when you draw the horizontal line on the graph, so the intersection should be, okay, at maximum it only can be one intersection at a time. So if you find out that there is more than one intersection, that means that the following function does not have inverse function. Okay, and another important condition that you need to fulfill is that following graph should be a one-to-one relation. Okay, so basically you must have two conditions. The first one is the intersection between the horizontal line and the graph should be only one at a time. Okay, and the second is the relation of a graph should be one-to-one function. Okay, so enough with the explanation, let's move on to the exercise. Okay, let us start with the question part A. So as you can see here, question part A, you have the function fx equals to 2x to the power of 1 over 3. Okay, so what we're going to do is, so we're going to draw a horizontal line. Okay, so basically you can draw this horizontal line any part, but make sure it is within the graph. Okay, within the graph over here. So let us start to draw. So we're going to draw at the top over here the horizontal line. Okay, so as you can see here, you only have one intersection. So okay, since you only have one intersection and this function is actually a one-to-one function, so this following function has an inverse function. Okay, so from here your question part A, the answer is has an inverse function. So this is your answer for the question part A. Okay, so from here let us proceed to the question part B. Okay, similar step. So you draw a horizontal line. Okay, so in this case we draw at the bottom part. Okay, as you can see here, it is only intersecting one point at a time, and this function is actually a one-to-one relation. Okay, so from here it is fulfilling the two major conditions, so we can conclude that this following function has an inverse function. So that will be our solution for the question part B. So let me write it down. Has an inverse function. Okay, so let us move on to the last part, which is the question part C. So as you can see here, the function fx equals to half x cubed minus 5x. Okay, so let us perform the horizontal line test. So in this case we perform at the top. Okay, so you draw a horizontal straight line. Okay, so as you can see here, you have more than one intersection. So let us calculate how much intersection you have. So you have 1, 2 and 3. Okay, you have 3 intersection, and this function, even though it is a one-to-one function, but it does not fulfill the major condition, which is it must intersect only one point at a time. Okay, but in this case it intersecting 3 points at a time, so we can conclude that this following function does not have an inverse function. Okay, so let me write it down. Okay, so let me write here no inverse function. Okay, no inverse function. Okay, so that is all for the step-by-step working and solution for this question. If you like this video, please give it a thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.